Hi, everyone. So, as we continue some more science air prep practice, let's move on to number 12 as I read it to you. Students investigate how mass and force affect the motion of a cart. For trial one, so meaning the first time they did the experiment, they used an empty cart. They placed the cart on a straight, smooth track. A student applies a brief force to the resting cart to move it on the track. When the cart crosses the start line, the force is removed and a stopwatch starts timing. The students record that for trial one, the cart travels 25 centimeters, which is the distance, in 5 seconds. This diagram shows how they set up the experiment. So let's take a look. We've got the cart. Our start line was at 0 centimeters, and then they went all the way up to 100 centimeters in case that cart went that far. So the students performed 2 more trials. Okay, remember that means they just did the experiment 2 more times. The second time they did it, they changed the amount of force used to push the cart. For trial 3, they changed the mass by adding more bricks. Enter a number in the table to predict the distance traveled by the cart in 5 seconds after it crosses the start line for the trials 2 and 3. This is important. There may be more than one correct answer. Okay. So in this table, they tell you the first trial had an empty cart. They applied 1 Newton. That was the force. Okay. How far did it go? 25 centimeters. So with an empty cart at 1 Newton, it went 25 centimeters. So now they're asking you to predict what would be an educated guess. You still have an empty cart, but now you applied a force of 2 newtons. So from 1 newton to 2, isn't that double, ladies and gents? So an educated guess would be it went double 25. Double 25 centimeters, which is 50 centimeters. That would be a very good, educated, scientific guess. Okay. Now, if you said 40, I'm sure they'll take that answer. But I think 50 is right where you should be. Now, trial 3, they added bricks to it and applied that force of 1 Newton. So at 1 Newton with an empty cart, it had 25 centimeters. So at 1 Newton with a cart carrying bricks, is it going to go as far as 25 centimeters because at larger mass, ladies and gents? I don't think so. So we got to make sure there's an answer below 25 centimeters. Okay. Probably not 24 centimeters, probably not 23 centimeters. I think an educated guess would be like 15, or let's just say anywhere from 10 to 15 centimeters would be good. Okay. Probably not 0 because you're applying a force of 1 Newton. So it's going to go somewhere. Okay. So again, remember, this is important. They said it may have more than one correct answer. Okay. So let's move on to number 12. A ball moves across the table. The ball moves from right to left, as shown by this blue arrow. Forces can be applied to that moving ball. The red arrows indicate those forces and show the direction each force would act on the ball. Place the correct force effect label that each force would have on the ball's motion into that blank box. Place only one label in the box. So we got to look at, okay, you have change direction, slow down, or speed up. If our ball is here and you're applying a force coming from this side of the ball, and the ball is moving from right to left, what would be going on right down here? Okay, so if the ball's coming down here, you apply a force from the right side, it will change direction. Okay, then here, because the ball is in motion right to left already, I know that because of blue arrow, if I applied a force in that same direction, it will speed up the ball.